Rate of change and slope, you're going to see that these two things are pretty much the same. Rate of change, you'll hear that talked about more when you have actual quantities attached to the numbers, like $3 per 1 gallon of gas. And slope, you're going to hear attached more when you're looking at a line or looking at an equation, but you're going to see that these two things are essentially the same. Our target today is that I can find rates of change and slope. So let's kind of flash back a little bit. Remember, ratios compare two quantities, such as 3 to 1, $3 to 1 gallon. And that would be the rate. The rate has the quantity with units in there. So therefore, a rate of change, so rate, okay, it compares the changes, like we had a rate of dollars to gallons of gas. Rate of change compares the changes in the independent and the dependent variables. And you'll remember from last chapter, the independent variable, this is your x variable. It's the one that causes the change. The dependent variable, these are your y values. They're the ones that are determined by the independent variable. So rate of change is going to be equal to the change in your dependent variable, which is your y value, over divided by the change in your independent variable. So let's look at rate of change with number of pencils and the cost for those pencils. So let's see, is the rate of change constant with respect to the number of pencils purchased? So on our number of pencils up top here, it's going up by 3. It goes up by 3 again. But here, then it goes up by 5. Now this is okay, because it's not saying is the change constant, it's saying is the rate of change constant. Let's come down here. Here, the change is it's going up by 75 cents. Here, it's going up by, again, 75 cents. So we can see from 1 to 4 pencils and from 4 to 7 pencils, yes, that's constant. Here, however, it goes up by $1.25. So we want to see, are these constant? So I want to see, is 3 over 0.75, is that equal to 5 over 11, not 11, I'm sorry, that should be a plus sign there. Okay, let's erase that. That should be 125. So we want to see, are these two rates of change the same? Lots of ways you could go about this. The way that I look at it is 3 compared to 0.75. Well, I'm thinking money when I see that, because 3/4 is 75 cents. Are 5/4 $1.25? Yes, they are the same. You could also cross multiply. When you multiply 3 by 1.25, you're going to get 3.75. And when you multiply 5 by 0.75, you're going to get 3.75. So those two are equivalent. So yes, the rate of change is constant. Now here's where we start to look at rate of change as slope when we're dealing with lines. So think of slope as the steepness of the line. Like you would think of a ski slope. Is it very steep, or is it more of a gradual? Think of it that way. Okay, now different ways that you can find slope, and you'll hear me express this in all these ways. So slope can be thought of as the vertical change over the horizontal change, and that makes sense when we're talking about independent and dependent variables. Your vertical change, that is based on your y-axis going up and down, and the y values are your dependent variables. Over the horizontal change, which is your x values, your independent variables. You'll also hear this as the rise over the run. You rise up, and then you run side to side. And then finally, the change in y over change in x. You'll also see that written. Sometimes I'll have a delta, change in y over change in x. That delta means change, and we just write that because it's quicker to write than the word change. Now take a look at this picture. Let's get rid of that screen shade and make this bigger. When you look at this graph, you have 2 points right here, and I could pick any other 2 points on there. I'm choosing those because they're on the crosshairs of the graph. If I were to pick, like, there is a point right there, but it's hard to tell. Is that 4.2? Is it 4.25? Is it 4.3? That's hard to see, so we don't use that point. We use where we know for certain the coordinates. So we have the coordinates 1, 2, and 2, 5. To find the slope of those, I want to look at the vertical change over the horizontal change. So vertically, it's going up 1, 2, 3 blocks. And you'll see right here, the rise is 3. The horizontal change, the run, is it's just going over 1 block. And so these red lines right here, those aren't part of the line, and that's just where we're showing the horizontal and the vertical change there. So the run is 1 block. Now these are both positives because I'm going up 3 and I'm going to the right 1. Up is positive and right is positive. Now even if I had decided to go start with 2, 5, I would be going left 1 and going down 3. So that would be -3 over -1, which still equals +3. So it doesn't matter which coordinate you start with. They actually subtracted the coordinates. When you're doing a graph, I think it's easier just to count the blocks, but if you're just given 2 points like you're going to see, you're going to want to subtract those values. So they subtracted 5 minus 2 and got 3, then they subtracted 2 minus 1 and got 1. So the slope is 3 over 1. If it turns out to be a whole number, go ahead and convert that to a whole number. And really, if you left it at 3 over 1, it's not going to be that big of a deal. But if that had been 3 over 2, don't change it to 1.5. Keep it as 3 over 2. That way it's a comparison still between two numbers. Here we're going to find the slope of a line passing through 2 coordinates here. So remember, we're wanting change in y over the change in x. So the change in my y values, I have -1, and then I'm going to subtract 3. Put that over the change in my x values, 4 minus 1. -1 minus 3 is -4, and 4 minus 1 is 3. So my slope is -4 over 3. Now let's say that I had started with that other coordinate first. That's fine as long as I keep it consistent. I would have 3 minus -1 over, and then do my x values, 1 minus 4. 3 minus -1 is +4. And 1 minus 4 is -3. And we know that -4 over 3 is equivalent to -4 over 3. It'd be the same thing. You don't have to draw this bottom part down here, but I do want you to get a picture in your notes of these 4 different looks of slopes. So if it's going up like this, and when you're reading it left or right, is the line increasing, and that would be a positive slope by just looking at it. If it's going down, that's going to be a negative slope, it's decreasing. If it's a horizontal line, that is 0 slope. There is no steepness to that line. If it's a vertical line, this is undefined slope because this is not going to be a function. Think about when we did that vertical line test. There would be lots of points. All the points would fall on that vertical line. So this right here is not a function. And so that's why the slope is undefined, because the slope doesn't exist for that line. Here you have a not very steep line, so it's going to have a very small slope. A little steeper, it's going to have a slope of 1. Even steeper, slope of 2. The slope of 4 would be almost vertical. Kind of gives you an idea for what those slopes would look like.